Today we're going to be looking at a few different exponent rules. So the first one is called the multiplication rule. So we have x to the fifth, x to the third written out, so 5 x's and 3 x's. 1, 2, 3, 4, 5, 6, 7, 8, giving us a total of 8 x's, or x to the 8. Here, a2, so I have 2 a's. a7, so I have 7 a's. Okay, so that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9. So a to the 9. When we multiply our bases, so when they're right next to each other, we add our exponents. So we can see 5 plus 3 does equal 8, 2 plus 7 does equal 9. All right, moving on to our division rule. So this is kind of like the opposite of the multiplication rule. So I have x to the 6, x squared, or 2 x's on the bottom, and then one on top, one on bottom, they cancel, and you're left with 1, 2, 3, 4 x's in the top, or x to the 4. Here, so 8 x's in the top, and 3 x's in the bottom. One on top, one on bottom, cancel, 1, 2, 3, 4, 5 left over. So when we divide our bases, we subtract our exponents. And we can see, so 6 minus 2 does equal 4, 8 minus 3 does equal 5. Moving on to power of a power. So this is saying 4 copies of 3 x's. So 3 x's, 1, 2, 3, 4 copies. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, or x to the 12. So here I have 5 copies of 2 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's, or x to the 10. Okay, and we can see, so if we multiplied 4 times 3, that would give us 12. 5 times 2, that would give us 10. So when we have an exponent outside of a parentheses, you multiply the exponents. Just make sure that the exponent goes to everything inside the parentheses, so it goes to every single exponent. Okay? All right, so moving on to our last rule is the exponent of 0. Any term raised to the power of 0 equals 1. So 5 to the 0 equals 1, y to the 0 equals 1, p to the 0 equals 1, but the whole thing doesn't equal 1, just this part. And then 438 times 1 is 438. All right, so now we're going to apply our division rule. 7 minus 7 is 0, and then anything to the 0 power is 1.